All right, so again, our notes today are going to be on this worksheet that you got in class today. And this is actually going to be our notes page for the next 2 days. So we're going to do some of it here and then some of it tomorrow night. So today we're going to just be talking about how to find an inverse and how to verify an inverse. So up at the top we give you the definition of inverse. Two functions are inverses if you compose them, f of g, and you get x as an answer, or when you compose them, g of f, and get x as your answer. So one of the things we're going to do to verify is compose functions. So that's when you plug a function into another function. But sometimes we have to also find that inverse so that we can verify. So I'm gonna go through numbers 1 and 3 with you guys today. We're gonna save the graphing. That's one of the things we're gonna do next time. So the sketching part we'll do next time. Today we're just going to look at finding and verifying. So we're going to do 1 and 3 together now, and we'll save 2 and 4 for in class. So you can make yourself a little note, 2 and 4 in class. And then all the graphing, which includes what's on the back, we're going to do that in the next night. So let's go ahead and get started. To find an inverse, so our first question here is to find an inverse. This is a 3-step process. Step 1, put y in for f of x. Zoom in a little more. So I'm going to write this as y equals 2x minus 1. Step 2, switch x and y. So I'm going to switch x and y and make it x equals 2y minus 1. Step 3, solve for y. So when I get y by itself, I'll have x plus 1 all divided by 2 equals y. That final answer after you solve for y is called your inverse. This here is our symbol for inverse, the little -1, just like an inverse sine or inverse cosine or inverse tangent. That -1 means the same thing with a function. It means an inverse. So for that first question, find the inverse, that would be our answer. Now when it comes to the verifying, so this, we can also write this as f inverse of x. So we have to show that when we plug the inverse into our function, we get out x. And as well as when we plug our function into the inverse, we get out y. So we have to kind of think to our difference quotient, how we plugged in a whole equation for x. That's what we're doing when we compose here. We're plugging a whole function in for x. So I'm going to start with f of f inverse of x. So this is telling me what I'm plugging in. So my f inverse is this equation I just found. I'm going to plug that in for x in f. So this is going to say, so I'm going to have my 2 times, now instead of x, I'm putting this whole equation in, minus 1. When I simplify this, the 2's will cancel, so x plus 1 minus 1. The 1's cancel, we get x. And that's the goal. If these are in fact inverses, we need to get x. That's what our definition up here says, is that when we compose them, we get x as our answer. But we also have to show the other direction. So we also have to show f inverse of f of x. So what this means is we're going to take our function f of x that we were given and plug it in for x in the inverse, and again simplify. So here we start off with our x, so that's going to be 2x minus 1. We're going to plug our function f in, plus 1 divided by 2. On top, because we're adding, we can add like terms, meaning the 1's cancel out, leaving us 2x over 2. The 2's cancel out, giving us x, which again is what we want. So once you've shown that both of these compositions equal x, it's verified. So what we're working on tonight in preparation for in class tomorrow is the finding, so following these 3 steps to find the inverse, as well as the 2 compositions to verify the inverse. Okay, we'll do the graphing another night, or tomorrow night. Okay, we're going to do another one, and then we'll have 2 more to do in class. So let's look down at number 3. We're going to go and follow the same directions. I'm not going to list out all the steps here for finding the inverse, but we're going to start by finding the inverse. So step 1, I'm going to change f of x to y. Then I'm going to switch x and y. And then I'm going to solve for y. So I'm going to subtract 1. And then to get rid of something cubed, we have to cube root it. So this would be our inverse. So for the first part, that is our answer, finding the inverse. The second part, we have to verify. So let's start with f of the inverse. So we're going to plug the inverse in for x in our equation. So x to the third, so instead of x, we're going to plug in this whole equation we just found, the cubed root of x minus 1 to the third plus 1. The cubed root and the third, well, those cancel each other out because cubed root and cubing are inverse operations. So we have x minus 1 plus 1. Those add up to 0, leaving us with x. And again, that's what we want, so we know we're on the right track. Then we have to check the other direction, the inverse f of x, and compose those two. So here I'm going to be using this function and plugging f into f inverse. So the cubed root, now instead of x, I'm going to write x to the third plus 1 minus 1. Now inside, again, because it's adding, we can write this as the cubed root of x to the third plus 1 minus 1. So the 1's cancel out. We get the cubed root of x to the third. Again, a cubed root and a cubed cancel each other out, leaving us with just x, which again is what we want. So tomorrow in class, all we're doing is finding an inverse and verifying an inverse. So like I said, we're gonna do 2 and 4 in class. If you want to try them on your own tonight to see how you do, then when we go through it, you'll be able to check it. If you don't feel confident enough to do that, we're going to go through them in class. And then again, the graphing part and the existence of an inverse we'll talk about in the next night.